This is quiz 13. In problem number 1, you had to calculate g prime of pi over 3. And what you knew was that g of x was given as this weird thing, f of x sine of x, which means f of x times sine x. So in order to calculate the derivative at pi over 3, you need to calculate the derivative first anywhere at x. And since this is a product, you've got to use the product rule. So it's the first times the derivative of the second. Derivative of sine is easy enough. That's cosine. Plus the second, which is sine, times the derivative of the first, which is, well, f prime of x. I don't know. But now we can go ahead and plug in what x is, because we want the derivative of g at pi over 3. So the answer is going to be f of pi over 3 times the cosine of pi over 3. Well, the cosine of pi over 3 is, on the unit circle, if you think of it, pi over 3 is a third of the way to pi, so that would be a 60-degree angle. And the cosine would then be the short side of a 30-60 triangle, and so that would be 1/2. And then sine of pi over 3 would be the long side of a 30-60 triangle, so that would be square root of 3 over 2. And then this would be f prime of pi over 3. All right, now the given information in the problem is that f of pi over 3 is known to be 4. So this is 4 times 1/2. And then you have square root of 3 over 2 times f prime, and that was given, f prime at pi over 3 is given as -2. So your final answer is going to be 2 minus square root of 3. All right, so that's number 1. Number 2, you're supposed to figure out where the graph of e to the x cosine of x has a horizontal tangent line. Well, that would mean where the derivative is equal to 0. So we calculate the derivative of this thing, again with the product rule. So we get the first times the derivative of the second. Derivative of cosine is going to be minus the sine. So if you get this minus, and I'll stick it out in front, first times derivative of the second plus the second, which is cosine of x, times the derivative of the first, and that's just going to be e to the x again. And we want to know where is that going to give us a horizontal tangent line. So this means that we want to set the derivative equal to 0 and solve this equation. Well, obviously I can factor out an e to the x, leaving me with, if I write this term first, cosine of x minus sine of x equals 0. Now, the thing is, e to the x can never be 0. Remember, the graph of e to the x looks like this. So we can divide both sides by e to the x, and that's never going to cause a problem. The product of these two things can only be 0 when one or the other is 0. This one cannot be, so it must mean that this must be 0. And the only way cosine of x minus sine of x can be equal to 0 is for cosine of x to be equal to sine of x. So where is cosine of x equal to sine of x? Again, if we turn to the unit circle, we can tell pretty easily that the sine and cosine are equal at a 45-degree angle, and way down here in the third quadrant, because there we've got a sine and cosine that are both negative. So our answers are going to be basically pi over 4, that puts us in the first quadrant, and 1, 2, 3, 4, 5 pi over 4, which puts us in the third quadrant. So those would be our basic answers, and then if you take and add on any multiple of 2 pi, so you could write this as 2n pi, where n is any integer, then that'll give you all of the solutions. So those are the places where the cosine and the sine are equal. Those are the places where cosine of x minus sine of x is equal to 0. Those will be the places where the derivative is equal to 0. And those will be the places where the graph of e to the x cosine of x will have a horizontal tangent line. And that takes care of number 2. Number 3, you were supposed to find the limit as x approaches 0 of sine 3x over x. And what you know is that the sine of theta over theta, where you take the limit as theta goes to 0, you know that this is 1. So you think of 3x as your theta, and so what you'd really like to do is get sine of 3x over 3x. So you can make it that way. You can just go limit x goes to 0 of sine 3x over 3x. Well, wait a minute, that changes the problem. We can't do that. So, quick, fudge out that 3. Cancel out that 3. So isn't this exactly the same as that? Of course it is, because the 3's are going to cancel. But if you look at this, the sine of 3x over 3x, as x goes to 0, 3x goes to 0, 3x goes to 0. This is like a theta that's going to 0. And so the limit of this part is just 1. And so the limit of a product is the product of limits, so you get 1 times 3, and the answer is 3. And that's the end of quiz 13.